Hey, welcome to the Fab-It-All channel, where I do machining videos and fabrication and DIY projects. So I've been doing some fun projects. We've been working on a go-kart. It's probably about 80% complete. I pushed that off to the side. I've been working on a bigger project that I think is better for the channel at this stage. I'm working on a robotic arm, and it's really neat. I alluded to this on the last video with the titanium rings. And I showed a few little sneak peeks of that. There won't be any sneak peeks in this video, but this is going to be purely a machining setup. I need to make a mini pallet. A mini pallet is essentially a flat plate with holes in it, so you can fasten things to it. I want to do something different with mine. I've always needed a mini pallet. I've done a lot of things where it'd be nice to bolt it down, hold small parts. So this is a good opportunity to do that. So let's get right into it, and I'll show you what the plan is, and I'll walk you through each component of it. Say Fab-It-All.
Hello. Let's go.
This animation will show you some of the different components that I'm going to be putting into this mini pallet.
So here is the pallet in all its digital glory. Stock I'll be removing, starting with a slightly larger 8" by 8" by 1.5" piece. And then the same thing, just color coded all the operations. We'll go through each one individually. A lot of little steps to do on this. So this is the main piece. This is the counter bore on the bottom to take an adapter, so I can put it in the rotary table and the lathe. And then these are just for the bolts to hold that adapter on. This is just a center locating hole. I'm going to do it very precise, 0.750 plus or minus half a thou. This is the step. This allows me to put it in my smaller vise, and also it gives me a step so I can clamp to the pallet if it's down flat on a surface. And all the 1/4-20 holes, I think 64 of them, drilled and tapped all the way through. And then these are the 3/8-16 holes. I'm going to do some more of those than just that. It won't be that hard to do that. That's how I drew it, but it should be an easy offset.
So here's what I got to start with. This is a ATP5. It's a cast aluminum. I'm not as familiar with this material as 6061. I haven't really worked with it, but apparently this is what it's made for, is tooling. It's called a tooling aluminum, or fixture jig something or other. I can't remember, but it was a really good price. It wasn't bad. So this is an 8x8 square chunk. I've got about 30 thousandths aside. I'm going to end up with 8" by 8", or really, I'm looking for some tight tolerance. So plus or minus a thou. So I got 30 thousandths to play with on each side, which is okay. So I just saw in there the animation, all the holes, they'll all be drilled and tapped with the 3/8. This is the side that'll be counterbored, holes for the rotary table fixture, and then this is going to be a locating hole, so I'm going to make this one very true. I think I'm going to do it on the lathe, but we'll get into that. I had that idea later. So 1.5" thick. It's actually quite square for being a saw cut, a precision saw cut. It's only about 7 thousandths out of square. So this is the bottom side. I'm going to be taking out all around here to make a step. So let's get the first step is going to be cutting out this because I got a DRO on my smaller knee mill that I can do these holes and run around the outside. My big Maserati doesn't have that, so I got to So this will take a little bit more time, but I can take a big amount all in one cut. So let's go to the next. All right, so there you have it. there's my version of a mini pallet. It's good for the mill and the lathe. So I've made this adapter. This fits exactly into the center hole of my rotary table. And then I made it so it bolts onto the back here and it fits nice and snug. And then 4 bolt holes. So I can either put it in the rotary table and then it's indexed, or hold it on with the lathe with the 3 jaw, or of course use the 4 jaw. And I made this recessed part to slightly smaller than the widest setting on my jaw for my smallest medium-sized jaw. And then I did 1/4 20 holes and then 3/8 16 in intermediate areas. A lot of drilling and tapping. So I also made this center hole. I kind of did this a little bit crazier than I usually do. I made the center hole exactly within 1/10 of a thou. I made that 0.75. I think it's 0.74999 is what it is. Or I think it's 0.75001, which is incredible that I was even able to get that using the boring head. But I wanted to be able to dial in off of that perfectly where it needs to go. Also, for this, the reason why I made this, I'm going to make some adapters to go in here, because on the robotic arm project, I want to be able to use this to hold different parts to cut some radii on some end fittings. Let me take you over to the mill on the rotary table and I'll show you how I'm going to set that up. So this is an example of kind of a set fixture for the rotary table. So see, mine has this recessed hole, and it has some holes in it for whatever reason. They're a 5/16 tapped hole. And what I did is I have these counterbore holes that match those holes down in the rotor table perfectly. So what I was saying is, instead of just making a set, this was a job that I was doing where I just needed to index these to the center. I was doing a flange, and didn't matter where I was. Instead of doing that, now I have this mini pallet. I can put this down in here sometime. It is perfectly fit. It is really, I mean, there's no slop in that. And then you can bolt this down somehow here. Just play nice. Oh, that hole does not want to play. That one's gone. Put something in this other hole. Got to blow it out. So I put that down, bolt that down, and put that over. I left my bolts up in the office, and then bolt that down to that index piece, and it actually is set. I have this set so it's at 0. So put that over there, bolt it down, and now you have the mini pallet can be used here. But then I can also just clamp it in the vise, and everything's pure and parallel to each other. Everything was drilled and done. All these holes were done together, so that it never changed off the setup. And I think parallel and parallelism on it is within, I think, half a thou. Size-wise, I'm within a thou on my width. I went for 8-inch. And then I used that, whatever I said it was, that cast aluminum, so it's dimensionally stable. So it's a really nice pallet, and then I stone the top of it just to take out any swirl marks, and it's actually really smooth. It looks, my mill was trammed in really good, and it turned out, using that big 3-inch head, it actually, a fly cutter would have been better, but it turned out really good. I mean, I don't have a comparator to check that smoothness or a smoothness comparator, but it's nice. So that's it. Can't remember how many holes. You can count them. And that's the back side. But it turned out nice. I'm gonna make things a lot faster on this project because I won't have to set up so many things, especially for cutting these radii on the outside. I was doing it by hand. It was too messy, too much work. So I'll see you on the next video.
Spider roll. Awesome. Make that like. Oh yes. Come on in, Patrick. So.